Hello class, today we're on lesson number 6 and we're going to be factoring trinomial squares. So we're going to revert back to some things that we've already learned and we're going to need to now expand our knowledge based on that because there are some complexities to algebra, but if we're able to recognize certain opportunities, our work gets a lot easier. Let's take a look here and we're going to read this in Korean, maybe not. What we do have here is an illustration from a Korean algebra book showing how to square a binomial. And the column on the left illustrates the result of squaring the binomial sum. And we have a plus b squared. So if we look at the top here, now we obviously cannot read Korean, but we can read numbers, right, or letters such as a and b, and we can see math. So math is universal. And fortunately, they're not using other characters. It would be a lot harder. But we see right at the very top, that first little square where it has a 1, and we see a plus b, and that's being squared. And we see that it's equal to a squared plus 2ab plus b squared. And we know that. And we look to the right, we see a minus b in parentheses. That whole binomial is being squared. And we end up with a squared minus 2ab plus b squared. Okay, so you can do math in any language. It is applicable. Now let's look down further, and we can see where we have the same way that we had learned how to multiply the a plus b and times a plus b, both of them being binomials in parentheses, and the a minus b, excuse me, times a minus b. But we see that, and we're reading at the very bottom, in both cases the result is a trinomial whose first and last terms are the squares of the terms of the binomial, right? We know that. Let's take a look again. Let's write it on our board. We have parentheses a plus b squared. Let's start with a plus b. My end parentheses are really getting a little sloppy there. I gotta make them a little bigger. But we're squaring this binomial a plus b. And what we just read is that we can see that the first and the last terms are the squares of the terms of the binomial, right? We have a squared and we have plus b squared. And we know that the middle term is twice the product. So we have a squared, b squared, plus twice the product of a and b. Now we learned this again in a previous chapter. Now, because of this, it is added if the binomial is the sum, and it is subtracted if the binomial is a difference. So that's the only other thing. If we had a minus b, okay, and we would have, again, the square of both. Both of these are being squared, both terms, and then we would have 2ab. I'm sorry, we're adding over here. And the only difference here is that we're subtracting. So we see these patterns. And it's very important that we're able to apply the same pattern to much more complex trinomials. And we're obviously going to be given those in this particular lesson. Now, let's take a look at the top of page 477. If these equations are turned around, they can be used to factor polynomials that are trinomial squares. Okay, remember I promised you that we're going to learn something one way and then we're going to reverse it and learn it the other way. And the reason you learn it the one way is because we really want you to learn it the other way. It's much more important, this part. You should feel comfortable enough to understand how to square a binomial such as a plus b or a minus b, and you should be able to get this. Whether you use a box or whether you use the horizontal method, you should always come up with these trinomials, okay? And that's great. The same way one day you learned 2 times 3 is equal to 6, right? But one day you had to learn that, well, what was 6 equal to? Well, what if you divided it by 2? Well, you would get 3, right? 2 times 3. So we have to look at numbers different ways, and now we're looking at our expressions different ways. And you're going to see how helpful that will be in the future. So this is the time that we do all the grunt work. You have to do your homework. You have to do these problems several times over and over so that you begin to feel and recognize the opportunities here. So we have the trinomial of the form, and again, it's just this one right here. Okay, hold 1 second. Trinomial in the form of a squared plus 2ab plus b squared. We have that right here. All right, we've already written it here. Just going to put a little quote over it. Not that we ever quote these things, but just showing you where we have it. And we know that this is equal to this. And we also know that this is always equal to this. So we're looking to spot this form. We're looking to find, when we have a trinomial, say, is it an a squared plus 2ab minus b squared type of polynomial, trinomial expression? Is it? Or is it an a squared minus 2ab plus b squared polynomial? We're looking to see if there is an a and a b hidden within. And I say a and a b, and I'm not looking for the actual a or b, but I'm looking for those terms that would be representative within that polynomial to say, oh, I get it. This means we can factor it as an a plus b squared or an a minus b squared. So we're going to factor the other way. So let's take a look. It says here, it's not always easy to see whether or not a trinomial has one of these forms. The following examples show how to find whether a trinomial is the square of a binomial. Okay, so that's what these are. These are the squares of binomials. We're just squaring these binomials. Now let's take a look at our examples. And I'm going to keep this up here so that we can match what's going on above. So is it possible, or if possible, write 4x squared plus 12x plus 9 as the square of a binomial? Okay, well, let's write that down. First thing we should always do in math is write our problem down. I see students that don't like to write the original problem down. And the problem with that is that you separate yourself from the problem, and you're looking at the page, and it really just opens up a great opportunity for transposition errors. You're reading off a different page, you're looking over onto another page, and it's sometimes just that alone can be the cause of many errors. So write it down and double check it. 4x squared plus 12x plus 9. Okay, it's there, particularly as you get more advanced. And when you step into Algebra 2, some of these problems are going to be so complex, but they're really going to be simple if you recognize how to factor. Now, let's see. It says the first term of the square the first term is the square of 2x. We can write 4x squared as 2x times 2x, right? We can write that because it will be 2 times 2 is 4, and x times x is x squared. So we know that we have that part, all right? And then we can certainly write this as 2x squared. Remember, we have to put in parentheses. We have to pull it out. And we know that the last term is the square of 3, right? We can certainly write this as 3 squared. We don't have to put parentheses there, but you could if you feel better. Now, the question is the middle term twice the product of 2x and 3? Because what are our a and b? Let's go back here now. We're looking at, this is all plus, 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 so let's take a look at this particular one. You could have looked at either one, but we don't want to confuse things with this negative. So we have a squared plus 2ab plus b squared. So what is the a term? What is being squared in this side? And we would say that would be 2x, right? So we would need a 2x. And then what's being squared? What's the b? Well, 3 is. So that would be 3. Why? Because we have a times b, right? So we have a times b, and then we're supposed to multiply that by 2 according to what this form is. Now, is this true? Okay, this would all be addition because they're all positive. The question is, when you multiply 2 times 2x times 3, what do you get? Well, you actually get 12x, because you would have 2x squared, in parentheses, plus 2 times 3 is 6 times 2x is 12x. Wonderful. Plus, then we have 3 squared. So we can definitely say that it fits. It's the same as the form of a squared plus 2ab plus b squared. Now, if that is the case, then what are the a and b terms? Well, we already said it's 2x and 3, and since they're being added, we would simply add it and then square this binomial. This is the 4x squared plus 12x plus 9 polynomial can be rewritten as the square of this binomial 2x plus 3. Now, it took work. What do we have to do? Well, we had to figure out what is again, what is the square, or what is the term that is being squared in 4x squared? We could say 2x. 3 is being squared to get 9. Well, we have our a and b terms. That would be 2x and 3. And if we did this, 2x times 3 times 2, yes, it does match. So we now have we have this as the square of a binomial. Okay, 2x plus 3, and that's being squared. Now let's take a look at the next one. If possible, write x squared plus 4x plus 16. Now let's write that over here. We have x squared plus 4x plus 16. Now I do see great opportunity here, but will it allow us to write it as the square of a binomial? Well, I have x squared. I'm going to go with 4x here, and I know that 16 is 4 squared, right? We're going to rewrite that. So now I've got my two squares on the side, and we're going to extract and say, well, we would have, if it were to be in this form, here's the test. Well, I have my x term, which is the a, or my a term, which is x, let's say, and I'm sorry, I'm going to write it over here, x, and then we have the y term, excuse me, the b term, which is 4, all right, because we have 4 squared, and then we would multiply this all by 2, right, because that's the way the form. So what do we have here? Well, I have a problem, because this would then be 8x, and 8x is not 4x. So that means that the middle term is giving us a problem, right? It is not twice their product. In fact, it is just the product. It would be 4 times x. So if it's not twice the product, then we cannot write this as a square of a binomial, okay? So this does not work. We would just say it cannot be written as a square of a binomial. Now, let me get a new board here and work on our next example. We have, if possible, now notice how much more complex they're getting, 25x to the 4th power minus 10x squared. Oof, it's getting really complicated. It's really not, because we're just going to simplify these things. Remember, if you're good with your exponents, if your exponents are easy to understand and you've done your work and you're getting more familiar with them as you keep doing these problems, you're going to be able to find the squares and you're going to see the perfect square. And we can see that 25x to the 4th is a perfect square. In fact, 25 is a perfect square that we can write as 5, right? And x to the 4th can be written as x squared. So we can say that this is 5x squared raised to the 2nd power. Can we not? Yeah, because we would square the 25, the 5, that would be 25. We would square the x squared, that would be x to the 4th, and we have our term. Now, the last term is 1, and that's really the easiest one, because you can say 1 squared as many times as you like, and it will always be equal to 1. So we can write this actually as 1 squared, okay? And I will do so here only so that you could see that there are 2 squares on the ends. Now the question is, what's the x and what's the, excuse me, I keep using the x and y. What is the a and what is the b? Because remember, we had a plus b, or in this case, we're doing it minus. There's a minus in there. So let's rewrite this as a minus b, right? And we have a minus b squared, and we know that's equal to a squared minus 2ab plus b squared. And you see how quickly I wrote that without referencing? I just know it, and you're going to need to know it. So there's your 2ab, and this is really where our source of challenge is going to come from. Can we get the negative 2ab out of this? Well, what is the a term? Well, the a term is 5x squared. Notice how it really got complex. You might say, well, why is there a square there? Well, because remember, it's 25x to the fourth power. The square, what we're squaring is 5x squared. We're squaring this entire term. So we just bumped up a little degree of difficulty. And we're multiplying that by 1, right? Because we'd multiply it by the b term. We're doing this, and then we're going to multiply all of this by 2 according to our form 2ab, and it's negative. So the question is this equal to that? Well, I suggest to you that if we multiply this, it will be, because we will now have 5x squared raised to the second power minus 10x squared. That's 1 times 2 is 2 times 5x squared is 10x squared plus 1 squared. So we do have an opportunity. What are our a and b terms? Well, the a term is 5x squared, and we know that we're subtracting, right? And we have 1 is our b term, and we're squaring this whole thing. So this can be written as a square of the binomial 5x squared minus 1. Okay, so as you can see, we're bumping it up, degree of difficulty, your biggest challenge. All right, the source of challenge is going to land right in here. Can we make a can we determine whether or not any of our trinomials are in this form? And we're going to need to see the 2ab. In this case, it was here. It was term 5x squared. It was term 1. That's your a and b. Multiply that by 2, and guess what? It's 10 squared, which is exactly what our original polynomial or trinomial to our problem was. So that is the end of lesson number 6.